Elementary particles such as electrons and photons are best described as wave packets. A wave packet is made up of a superposition of different waves, although most of the waves are centered around a certain central frequency. The superposition of these waves produces a wave pulse that is centered around a particular location in space. This wave pulse then travels through space with a velocity we call the group velocity. This wave packet model leads to an uncertainty in the quantum particle's position, momentum, and energy. This uncertainty is described by Heisenberg's uncertainty principle, where delta x is the uncertainty in the position of the particle in the x direction, and delta p is the uncertainty in the momentum in the x direction. We use the uncertainty principle to help us gauge when even quantum mechanics cannot tell us the exact position, momentum, or even energy of a quantum particle. Because Planck's constant is so small, this really only becomes relevant for very small particles with small mass, or problems dealing with small energies and short timescales. The Heisenberg uncertainty principle for position and momentum can be derived rigorously from quantum mechanics, but since we only use it as a rule of thumb, we often write it without the factor of 1/2. The Heisenberg uncertainty principle relating energy and time is less rigorously derived. However, it is quite useful in understanding the time it takes for a quantum particle to transition from one state to another.